Hi friends, today here we are going to learn how to find the centroid of a L section. This is a L section where this horizontal dimension is 100, vertical is 50 and thickness is 10 mm. Now to first calculate the centroid of L section, we must know where the centroid of a rectangle comes. Now this is how to locate the centroid of a rectangle. Now this is a rectangle A, B, C and D. Now this, if I draw the diagonal AC and BD, then the point of intersection, that this point G where the diagonals meet, this is the centroid of a rectangle. Now if this horizontal dimension is B, then from the point D it is at a distance of B by 2 is x bar. So from point D to G, this horizontal dimension is B by 2 and the vertical dimension, suppose this AC vertical dimension is D, then this point G, this vertical distance from point D is D by 2 and that is y bar. Now if I give some dimensions to this rectangle, suppose the size of the rectangle B is equal to 200 and D is 50. This is the centroid G here and this is the point O here. Then from this O up to G, this distance is x bar and it is 200 by 2, that is 100 mm. And if this vertical dimension is 50 mm, then this vertical distance OG is y bar and it is D by 2 and it is 25 mm, that is half of 50. Now I can locate O anywhere. Suppose my O is not here at the bottom, but I take it at the top here, O. Then this OG distance will become x bar and again it is half of 200, that is 100 mm. And now this vertical distance from O, this location, this is y bar is equal to D by 2 and it is half of 50, that is 25 mm. So this is how we locate the centroid of a rectangle, that is the center of area. Now let us come to our problem, that is the L section. Now first step is, what we do is we split the area here. Now here I am showing the dotted line. Here I am splitting the rectangle. So what I do, split the area into number of areas such that the centroid of individual area is known to us. So here I have done the splitting. The bottom horizontal rectangle is called A1 and the top vertical rectangle I call it A2. Centroid of A2, here I am showing a G2 and this centroid of area 1 is G1. What we secondly do is we calculate the individual areas. Now if I calculate the area A1, it will be B1 into D1. B1 is 100 and D1 is 10. So 100 into 10, that is area A1 and that is 1000 mm square. Then I calculate the area A2. Now this total distance is 50. This thickness when I deduct it, because from this dotted line above is the area A2. This dimension is 40. So D2 is 40 and B2 is 10. So B2 into D2, that is 10 into 40, 400 mm square is area A2. This is the second step. In the third step, what we do is we fix the reference axis OX and OY. Now this is point O here and this horizontal axis, this is my reference axis OX, and here this vertical line, this is my axis OY. Now this is the center G1 here. So from O up to G1 is X1 and this will be B1 by 2, that is 100 by 2 is 50 mm, because this from here to here is 100. So half of it is 50. Now this vertical dimension is this horizontal distance for G2. This distance from here to here, that is from the axis OY up to G2, which I have shown here at the top, that is X2, that is B2 by 2. Now this thickness is 10, so half of 10 is 5 mm. So this G2 from this axis OY is X2 and that will be B2 by 2, 10 by 2, 5 mm. So This is how we calculate x1 and x2 from the reference axis OY. Then what we do is we calculate the y1 and y2 from the axis OX. Now this horizontal line is the axis OX, and this from this axis the distance g1, this vertical distance is y1. This total thickness is 10. So 10 by 2, 5 mm is my y1. This distance is y1 is equal to d1 by 2, that is 10 by 2 is 5 mm. And d2 is again from the axis OS up to g2. This vertical distance is called y2. So it will be d2 by 2, this dimension will be d2 by 2, that is 20, and plus this thickness 10. So d2 by 2 plus d1, that is 40 by 2 plus 10, 30 mm is y2. Here we have to remember that y2 is not only d by 2, because if I take d by 2, it is from here to this dotted line, whereas my reference line OX is here. So y2 is from the reference line OX up to g2, and it is 30 mm. This is how we calculate y1 and y2. After that, the next step is what we do is calculate x bar and y bar. The formula for x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2. Now substitute the values which we have calculated. A1 is 1000 into 50 plus 400 is a2, x2 is 5, and put it in the bracket divided by area a1 plus a2. Area a1 is 1000, a2 is 400. Put both the brackets very clearly so that there is no error in the calculation, and then we get the answer 37.1 mm, 37.14 mm from the axis OY. Similarly, for y bar, the formula is a1 y1 plus a2 y2 plus divided by a1 plus a2. These brackets here are very important. Don't miss the brackets. Now this is a substitute value a1, that is 1000, y1 that is 5, a2 400, y2 30. Again in the denominator a1 1000, a2 400. Keep the brackets at the top and at the bottom and calculate y bar, that will be 12.14 mm from the axis OX. Now how to show the x bar and y bar in the figure, and where is the centroid of the L section? Now this here I have shown the point G, centroid, and x bar is, this is the horizontal distance x bar from here to here, that is x bar is equal to 37.14 mm from the axis OY, and this vertical distance from here to here, that is y bar is equal to 12.14 mm. This distance is from the point G up to the axis OX. So y bar is from the axis OX. Now in the exam, you should draw only this figure. Here what is important to remember is this dotted line. This you must show where you have split the areas, then the reference line OX, OY, G1, this G1, this is G2, and the centroid G, x bar and y bar. This much is sufficient in the exam. Then write the area A1, x1 and the y1, A2, x2, y2. So write the formulas x bar, y bar, substitute the values, and then write the answer, highlight the answer and write the answer very clearly. Now few students, they write the formulas correctly, they substitute the values also correctly, but their answer is wrong because they make a mistake while doing the calculation. So here I have shown what are the buttons to be pressed in the calculator. So in this order, bracket open, 1000 into 50 plus 400 into 5 bracket close divided by bracket open 1000 plus 400 bracket close, and press equal to, you will get x bar. Similarly here for calculating y bar, these are the buttons to be pressed. Bracket open 1000 into 5 plus 400 into 30 bracket close divided by bracket open 1000 plus 400 bracket close is equal to, and here you will get the answer. So this is how few students, they don't know how to press the button, which button should be pressed. So this is the way you can calculate x bar and y bar for the L section. If you have understood how to calculate the L section, then here is the assignment. You can try these two L sections and calculate their x bar and y bar. I hope you have understood how to calculate the centroid of a L section. Thank you. All the best. May God bless you.